Hi everyone, welcome back to Dragonfly Engineering. So this week we're getting back on the in-house Dragonfly Engineering product, which is this molded tray right here, 24 well tray. So this is a follow-up to the episode where I debuted this project 2 weeks ago. So now what we're going to do is focus on EDM burning the Dragonfly Engineering logo into the mold itself on the A side. And then I'll discuss a little bit about reassembling this mold. And then in the subsequent episode, we're going to reload this mold into the molding machine. I had to actually pull the mold out because I had some logistics issues with the customer's job. So anyway, we didn't quite actually mold new parts yet. But soon we're going to reload this mold into the dual shot molding machine and mold some parts. So stay tuned to see the EDM process where we machine a copper EDM electrode and then load that into the EDM milling machine, RAM EDM, and burn in the Dragonfly Engineering logo over the old logo on this recycled mold. So enjoy the show. Thanks for watching. Okay, we're out next to the dual shot molding machine. We got some other molds loaded, and our 24 well tray mold is basically staged and ready to go. It's heavier than what my electric hoist can handle, so I got the old chain fall hoist up here. But what I wanted to do is show you the EDM logo that was burned in on top of the previous customer's logo. Again, this mold was given to me as long as I got rid of the customer's information. So right in there is the Dragonfly Engineering logo that was EDM burned. I'm using the cell phone here, cell phone camera. And yeah, it turned out pretty good. It's a mirror image, because this is the mold cavity. So the part itself will have a positive image of this text. Let me see if I can, there we go. So that was spark erosion machined logo into the edge of our part. And it says Dragonfly Engineering. So I am going to load this mold into the molding machine with another mold in the second location, maybe even one of these molds. I had an issue where I had to actually pull this mold out because I had logistical problems with the customer's run. So we haven't actually molded parts yet on this mold yet. So anyway, but the assembly of the mold is, the front end with all of the tubes. This is a kind of a continuation of the episode of a week and a half ago. So these are the wells, and then this is the stripper plate. Now let me lift up the back of this mold a little bit. It's pretty heavy, so anyway, so the stripper plate rides on these springs with some retainer bolts. That's one of them down there, which goes in this hole, and then this stripper plate basically pops the molded part off of the A side of the mold so that it can basically get pulled out from all of these posts, which has a lot of stiction force. And then the part is stuck on the B side, and you can see a partial shot of polypropylene there. So when I reload this mold and I fill this mold cavity completely with plastic, it will weld onto this existing polypro. And then all the ejector pins, which are back in this pocket area, you can see the ejector pins which pierce through this whole block. It will eject the tray off of the B side in all of these veins here. So anyway, we are getting ready to reload this mold, and I'll have to admit in another episode why we had to pull this mold off. But it was to get a customer's job going and out the door. So anyway, more to come about that. But this is the tray mold. I think I teased everyone and it said, let's assemble this mold, but then I just switched over to EDM machining of the tips of these posts in the previous episode. So now in this episode, we burned in our logo over there. And then probably the subsequent episode, we will reload this mold into the molding machine And Big Yellow will pull parts. That guy back there. All right, let's do it. So now I'll show you the process of EDM milling our logo into the A side of this mold, this molded part. Okay, we're over on the bench here, and this is an EDM electrode where we're going to burn in Dragonfly Engineering on top of an old logo in the mold that is in the EDM machine. So yeah, one of my customers have a legacy mold that they don't need anymore, so they said I could use it for whatever purposes I need, as long as I don't show their name or show any of their intellectual property. So we've burned off most of the features that they don't want, or burned off as in the EDM machine electro-eroded away sensitive features that are proprietary to the old customer, and their name is also on there. So we're going to use this copper electrode to electric spark, discharge, and machine away their logo that's on the mold and replace it with Dragonfly Engineering for our launch of a new product. So let's get this basically big electric eraser into our EDM fixture, and this is a A1 fixture. A1 is a company that copies R3 or 3R. Let me see, 3R fixturing, which is this thing. And so this is the interface that can go on your CNC mill, and then this fixture fits in here and locks down with a post that twists in. I'll show you this on the EDM machine when we actually run it. But on the EDM machine, the fixture is actually in the spindle, so it's hanging upside down. And then our tool fits in the spindle like that. So anyway, 3R, it's pretty good stuff. It's expensive, but very precise and high quality. So basically we just need to pass electricity through this fixture into our copper electrode. And I think we'll have the text facing out on the actual plastic tray. And yeah, so there's a set screw and an aluminum spacer, and we'll just basically clamp this thing down into the 1-inch pocket of this 3R clone of a tooling fixture and clamp it in. And it just basically just needs to be parallel. This is a cosmetic thing, so it's not like a structural item in the mold that has to be within a few microns or tenths of thousandths. So I'm not too worried about exact precision. It's more art than function. There we go. Here is our EDM new name that we're going to sink down into the mold. This EDM style is called a ram EDM because you ram an electrode down, or they're also called sinker EDMs because you sink your electrified electrode down into your mold face. You know, for instance, if this is our mold block, then this thing will just burn down through with electric spark erosion to create this shape in our part. All right, I'll meet you over at the EDM machine. Okay, here we are. So this machine is kind of noisy. Oh, here's the previous electrode that was used to burn off the tips of the posts for this tray, which I can show you some pictures of. And you can see all the soot here. This is EDM oil soot from probably about 1 day of EDM burning. So smoke comes, you know, this thing's hopping up and down, burning away the post, which is my finger. And then the smoke comes and kind of coats our fixture. This is the same kind of one that we're gonna load our new logo fixture in, except I've got a drill chuck for round parts, which makes it pretty easy to fixture round parts. So there you go. And that's the the burned or EDM burnished copper profile that we burned into the 24 posts in the mold. And we put our pull stud, this thing, into our fixture, and we rotate and then push in the retaining plastic ring, and then we're ready to load into the machine. After I turn it on, it's a little noisy. Powered down. I need to acknowledge that I turned it off. This thing is a little fussy. It's a Japanese machine, so a lot of times in my experience with Japanese milling machines, there's all these acknowledgments and safety warnings you need to acknowledge. So I had to acknowledge that I turned the power down, last time it turned off. So now I'm going to turn it back on. And there it goes. I don't know, my Haas milling machine or Herco milling machine, I don't have to acknowledge that I turned it off to turn it back on. But I guess the Sodic you do. Okay, now we're going to hit tool center point or tool change point, and this spindle is going to rotate a little bit and get ready to be aligned for changing tools, because there is a tool changer. This thing right here is a tool changer, so you can actually hang tools in here, but I hardly ever use that. Okay, and we are going to, one trick that I do is that there's writing on this fixture, A1, and I always face this writing towards me so that I don't mix up the orientation of the fixture. So this writing is going to come facing me. Let me stick that in there. Oh, I got to unclamp or acknowledge unclamp, and then put the fixture in and then tell it to clamp. Then I like to make sure that it's actually in there. And now what I will do is I will line up this electrode with the logo, which I can't show you on screen, but I could probably show you some things about using the indicator to square up this logo to the mold itself, or to the axes of this machine. So yeah, let's do that. So this is a tenths indicator, and it measures 1/10,000th of an inch per increment. Okay, I'm going to set this on the mold, and then with being able to see, I can then travel the electrode over to the indicator, and it may be a little too tall. Let's see what happens. So this is basically a DRO XYZ, and the machine will stop if it feels that there's an electrical short with your workpiece, and that's how you actually touch off and find the zero location. Is it slowly approaches, and then it feels a short circuit, and then says, oh, I'm in contact, so that's the 0 point, if you want to make it that your 0 point. But this indicator is floating with a peak plastic block, so it'll keep pushing this indicator over because there's no circuit to close, because I've intentionally isolated it from the ground of the rest of the machine. So I'll carefully bring it in. It looks like I'm going to have enough room for the ball to actually make contact. Here we go. Now what I'm going to do is start to rotate the spindle until I can sweep front to back, and this needle doesn't change direction at all. All right, I got it within about 0.3 or so, or that's about, I don't know, 10 microns. So I think we are square. So over on the controller, up here where it says U, that's the axis. I'm going to go to the MDI and I'm going to say G92U0. Oh wait, I got to click on the screen. G92U0, enter, and then you hit execute over here. And the U is now set to 0. So that's the spindle orientation, is U. All right, so now we are squared up to our mold, because I did a similar process with that indicator on the mold position in the platen itself. Yeah, so this mold block was squared up using this indicator in a similar process, except the indicator was mounted into the spindle, and then I swept the mold back and forth. Make sure you can't see the logo. All right. So now I think I'm going to visually align our electrode to where the logo is conveniently out of view of the viewer. So what I'm going to do is just drop the electrode down until it touches the mold surface, and then that will set the 0 of the Z. Hopefully I don't bottom out on travel. Doesn't look like I will. And then I'll bring the electrode close to the actual area of interest. I'm basically going to center it on the rib, or the top lip of the this tray, which is defined basically by this perimeter. I got a little. I'm gonna have to do some mold maintenance on this thing too. I see a little rust right there. Okay. All right, so I'm going to drop this electrode down until it touches and shorts out and tells the machine that's a 0. There we go. G92, which sets basically the coordinates of your work offset to 0. Oh wait, G92Z0, enter, and then hit execute over here, which is just off screen. So this is like you write the command and then enter for text editing, and then to actually execute the command, there's another enter key over here. And Z will be set to 0. We can do the same for X and Y, because we're not fine-tuned in, but this is roughly where it's going to be. So I'll say G92, X and Y. You don't have to write in 0. It assumes that you're setting it to 0 if you don't write 0. Again, enter for the text and then enter for the command. And now we're at X, Y, Z, 0, and spindle orientation U is 0. So now what I'm going to do is kind of get in there and take a look and fine-tune the location of our new burned-in logo to cover up the old one, and then we'll start the EDM milling process. We're going to lower the door, or the tank door. That's what this is. It holds all the oil. Yeah, this all fills with oil. So we can lower the door, tank door down. And I will start to set up the actual fine position. All right, we're going to go to the editor. We're going to define a new program, which basically just burn a hole into the top and we're gonna go minus 0.4 to start. Copper is the electrode, steel is the material. We're not going to do any kind of side milling because we're kind of just imprinting a text. So Lorraine pattern is off. If we had that on, or like a circle, then it would actually side mill, but we're not going to do that for this particular one. Projected surface area, it needs to know how big the area is. So we've got like 4 by 50, so 100. No, 200 square millimeters. Is that right? Let me measure this real quick. Oh, 6. Six by 70. So that would be 420 square millimeters. Well, we'll just go to the biggest number that they have. Okay, roughness. We'll do 10. It's microns surface roughness. You'd have to look that up in the surface roughness plate to see what that is. Undersize. Electrodes are always smaller than the actual shape they burn. So we're gonna say 0.1 millimeters. I probably should have undersized the text when we machined it, but we'll say okay. And yeah, let's see what happens. Okay, so we'll go to the run page, XYZ. I think I need to raise the tool off of the mold, otherwise it'll say you're shorted out. So we'll go up a little bit on Z. All right, and then I'll hit enter for run. And it'll start doing its thing, calculating away, and the door will raise up. Then the EDM oil will fill the tank. And we'll start burning away the old logo with the new. I got uniform spark pattern, which means that my electrode is pretty well parallel to the mold, which is a good sign. If I only saw sparks close to me or far away from me, then that means my interface has a triangular gap in it. You can see some black soot kind of pushing out, and that is basically parts of little tiny slag balls of steel plus burned dielectric oil, and CO2 is the bubbles coming off, or whatever you, I guess, reduce oil to from electric sparks in the absence of oxygen. Probably all sorts of weird, like organic polymer gases coming out of there. So the ram is hopping up and down ever so slightly to flush out the soot and the burned steel, and then it's going down for another bite. Alright, so here is the electrode after machining. So that's the machined text of the Dragonfly Engineering logo. And then that grayish color is I guess the discoloration you get after electric spark machining of the copper. It originally looked like that on the side, but after a bunch of spark erosion, it kind of gets this almost like an anodized look to it. And then that O right there is kind of interesting. See how that's darker? That's got captured soot in it because as this electrode was hopping up and down, it didn't have the soot clearing capability because it acts like its own little O-ring, pun intended. And the soot's captured in there a little bit more. Oh, anyway, but this guy was machined and loaded into one of these 3R collet holders, or not collet holders, but work holders, and a collet gets stuck in there. And it was in the spindle of the EDM machine, but I had to burn out a busted tap. So this is a piece of copper wire, and I used that to clear out a tap I broke off in something. Anyway. All right, so I've lubed up these guide pins, and then these 3 bolts are the bolts that retain the stripper plate onto these guide pins. So basically these springs don't shoot the whole stripper plate back off of the mold. These hold it in. So I will go ahead and pick this thing up and carefully string it onto our guide pins. I'm on this wooden little cart because I'm getting ready to load this mold into the dual shot molding machine. So it's not as ideal as if I had a steel table, but logistics are such that I'm assembling the mold here on this cart. I probably need to get, oh, here's a rubber mallet to convince it to go. And this is mostly just friction on this wood base instead of having the steel table. Got to make sure my springs don't pop out on the inside. This stripper plate also has cooling lines in it that, you know, basically we just have a big circuit. So the cooling, well, actually, I guess the cooling would start on the B side, the eject side, with this hose right here. And it would go through a U-shaped channel in the B side, and then a hose from here would then connect to the port for the U-shaped cooling channel in the stripper plate. And then finally, that water would go into this port, and then the cooling water would go through the matrix or the labyrinth of copper tubing and then drain out here. All right, we're getting there. Let me show you a different angle. Okay, now I'm up on those springs. So hopefully I can actually start these bolts and grab a thread and then use these bolts to compress the springs. Yeah, it looks like it's gonna grab. Yeah, so that thread did engage. Otherwise, I'd have to get a huge C-clamp and compress these massive die springs, which is probably like 700 pounds of force. All right, and then I need to, now these bolts are basically a matched set. They were like custom ground, and they go to bottomed out threaded holes in the mold block, so that this stripper plate, when it pushes forward, it's still parallel by the depth of these custom ground 3/8 bolts. There's nothing special about the bolts. But I do bottom them out and basically tighten them onto the bottom of the hole so that they don't slowly work their way out in production. I might need to get a shallow socket to, I don't know if I can start these with my fingertip or not. I think I got that one. All right, we're good. And then I'll just keep walking around and tightening down our retention bolts, which is compressing our stripper plate springs. Anyway, I can do all this a little later. But this is about the depth of the first eject, which, as this mold, you know, the A side is on the A side of the molding machine. This is the B side. When the molding clamp actually closes these, and this gap goes to 0, and that preloads the eject force to get the part off of the A side and keeping it on the B side, which does have more of a labyrinth. So theoretically, the part holds onto this with more affinity than these smoother round posts. But you really don't want your part to be stuck on the A side, because it would take forever to dig a polypropylene part of this complexity out of all of this matrix of little pins here. Okay, so I am going to flip this around. Now this mold is pretty tall, actually. In fact, I had to add an aluminum spacer on the back. Let me spin this. Because this mold is going to run in parallel with the large steel mold that I serviced about 2 weeks ago. And that mold is huge. It's like 1,200 pounds. And it's really tall. So this is basically just extra material that I had to add to the back of this mold, so that the height of both of these molds is identical, because the dual shot molding machine needs both molds to be exactly the same height to within like 5/1000ths of an inch, so the clamp doesn't get torqued. All right, so this is all getting kind of heavy now. I'll see if I can get these two mold halves together. This little cart that I have is handy for carting these super heavy molds around, and it's got like a 2,000 pound capacity, I believe, but it's kind of hard to rotate molds that weigh a lot. There we go. And then there is some drilling of small features in the back or in the bottom of this deep well B-side mold insert as well. So a lot of work for what is basically a free mold. There's still a lot of, modification work. So the parts that coming off of this mold are not freebies, because I probably did maybe 4 days of work on this off, you know, and that you're going to see in this episode or the next. So let's get it together. Okay. I still need to tighten that one, but yeah, let me just start this. Okay, we're going together. I'm just using a dead blow plastic mallet here. Ouch. All right, well, it's started. I do need to tighten that one bolt down there. But this is our production steel mold for that, our first product. So take a look at all of the other details throughout this episode. I'll probably voice over some of it, but there's just a lot of footage of machining the copper electrodes for the EDM process and some of the retrofit machining on the B side. And thank you for watching Dragonfly Engineering, and keep an eye out for the advertisements of our new product. Through this series, we're going to talk about how we develop the Amazon, you know, sales page and set up our account with Amazon and Shopify, and how we advertised with different online avenues to actually get our product out there for people to know that it exists and then buy it, and then hopefully give good reviews. So, and keep an eye out on dragonflyengineering.com if you'd like to buy your own tool tray for your shop. All right, well, thank you for watching, and I'll see you guys soon.